Alright guys, we're gonna do two examples. Okay, so to find the area of a regular polygon, keep in mind this is only for regular polygons. Okay, so right now for number one, I'm gonna zoom in on number one here. Okay, you have a regular hexagon. So the trick here is, first off, I'm just gonna give a little visual. I'm gonna split this up into our smaller triangles here. So remember, there's two formulas we can use, or quote-unquote formulas, right? They're really the same formula, but I guess two ways to conceptually solve this problem. Okay, so the first way, I'm just gonna stick with the number of triangles, okay? So the area of this polygon is gonna be the area of one triangle, right? Base times height, times how many triangles there are, right? N, okay? So for all of your problems, okay, for every single one, you need to start off here on the left side. You need to find the central angle, okay? Do we remember the formula for a central angle? Good job. It's 360 divided by n, okay, by the number of sides. So for this case, our central angle, 360 divided by, in this case, our n equals, how many sides we have? 6, okay? So our central angle is 60 degrees. Now this is gonna help us here because it's letting us know that this right here, this whole entire angle, okay, is 60 degrees. Now, if that rings a bell a bit, this is gonna be dealing with a 30, 60, 90 triangle. Okay, oops, sorry. Now the key here is all we need to do, guys, is really focus on this triangle here. This small triangle is all we need to focus on, okay? So again, just focusing on triangles. So I'm just gonna draw this triangle to the side here, and it's really gonna help us figure out what are we going to do in order to solve for that apothem, right? Or that height, right? This right here. So tricky enough, we know the whole thing is 60 degrees, right? This whole thing is 60 degrees, but half of it, right? Just this half right here is actually 30 degrees, right? So half is 30 degrees. Now, that would then lead this angle here to be 60 degrees, okay? Which is how we got a 30, 60. And we were actually given that the angle opposite the 60 degrees, okay, this angle right here, I'll make it blue, right? Opposite the 60, we were given that it was 5 radical 3, okay? So I'm just gonna write that really small here. 5 radical 3. Okay, so that's opposite the 60, boom. Okay, and then do you remember our ratio here? Okay, our ratio was x radical 3, and 2x, okay? Please make sure you review your special right triangles, okay? It is very important for your future math classes as well. So now we're doing this. To go from your 60 to your 30, you gotta divide by radical 3. So easy enough, this is just 5. And to get to your 90, you times, we're going from 30 to 90, you just times it by 2. So then you have 10. So let's kind of fill in this one triangle here. So opposite the 30, this here is 5. And opposite the 90 is from here to here, that is 10, okay? Now the most important piece is actually this 5 here. If this here is 5, then the other half has to be 5 as well, which then means the entire base, this entire base is 10. And I believe that's all we need for our formula. So plug it in. The area of this polygon, of this hexagon right here, is 1/2. My base, which we found out it is 10, that is my b, right? b equals 10. And my height, this height is the apothem here, which was given to us. The height of this triangle is 5 radical 3. And then how many triangles do I have? I have 6 of them, so multiply by 6. Simplify all of this, so you should get 150 times radical 3 centimeters squared. I know it says round to the nearest tenths, but if you get a whole radical like this, just leave it as a radical, unless it's like super weird decimals. In general, I prefer radicals over decimals, okay? So that would be your answer. Okay, and let's look at number 2 here. Again, feel free to pause anytime if you feel like you're lost to understand the work. Okay, for this one, I'm just gonna use the formula 1/2 times apothem times perimeter, okay? Again, these two are both the same formula. They're just written differently, and their conceptual process is just slightly different. Okay, but they both work. So for this one, yes, I know it's a regular triangle already, right? But we're just gonna keep practicing with our formula here. So I'm just gonna draw this. Okay, first important step to find out your, like back here, to find out your central angle. Okay, so your central angle, 360 divided by n. Okay, in this case, our n equals 3. So your central angle is 120. Okay, so this right here, this angle is 120. And then you always are going to take half of it. Okay, so again, I'm gonna just trace this out here. Take this. Okay, I'm gonna draw it out here. And the reason that 120, this whole thing again is 120, how that is gonna help us is because it's gonna give us half of it, right? We know that this half now is gonna be 60 degrees, which then means this little angle right here is 30. Okay, because your apothem, or aka the height of that triangle, is always going to be perpendicular, right? This line is always going to be perpendicular to the base. Okay, so now we know the whole thing is 14. And the fact that the whole thing is 14, we're going to know that each half is 7. Okay, and this is only true, again, I'm going to emphasize it, for a regular polygon. All right, so now we're going to work with our 30, 60, 90 again. 30, 60, 90. Okay, and our goal is just to find that apothem right there. So we know the 60 opposite that 60 is 7. So how do I go from 60 to my 30 degrees? I'm going to divide by radical 3. So I'm going to take this 7. Purple, I'm going to take the 7. And then I'm going to divide it by radical 3. And let's make sure we rationalize here now. So rationalizing it. 7 radical 3 over 3. Okay, and that would be your apothem. Okay, so this right here. Now once you have that, and you actually have your perimeter is what, 14 times 3 sides, which will get you 42. And that's really all you need, right? So your answer is 1/2 the apothem, which is 7 radical 3 over 3, times your perimeter, which is 42. Do a little math magic here. 3 and 42 is 14. 2 and 14 just becomes 7. So nicely enough, this is just 49 over radical 3 meter squared. Okay. Boom. Okay, there's 2 examples right there, each using this specific formula. And again, they're really the same thing. The problems down here are mainly just review, but they're good problems for you to kind of just process here. So I already gave you guys the work for it. It basically shows the majority of the work here, right? So just verbally talking about part B real quick. To find the area of the shaded region, okay, the S is for shaded region. you basically take the whole area, which is the rectangle, right? This whole entire area, and you need to subtract it by 3 circles. Okay, and then we're gonna assume that these 3 circles are the same. So to quickly define the base, if the radius is 5, this is 5, this is 5, this is 5, right? All of this is 5, which means this whole base is 30. And the height, same idea, the height is just going to be 10, right? Because this would then be 5, this is 5 as well. Okay, and really just plug it in here, and these are not required, but you can just try out 1 or 2 problems just to, you know, jog your brains real quick on how to solve for your areas of shaded regions. Okay, all right, good luck with your homework.